little bit about myself for those who haven't tuned in before. My name is Brad Panovich. I'm the chief meteorologist at WCNC here in Charlotte. Normally I do a ton of school talks every year. Last year I think I did 76 school talks, so many that I had to start pulling back. One of the things I love about going to schools is that a lot of kids obviously don't watch TV, but I got into TV because by accident. I love meteorology. I've loved it since I was 6 years old. I didn't want to be on TV. I love the science of weather. My degree is in atmospheric science from The Ohio State University. So I like to share my love and passion for weather with the kids. And so I do this presentation usually in about an hour. It involves just some simple experiments. We show tornado, but some of the cool principles of how the atmosphere works. Because one of the cool things about weather as far as teaching science is, science is amazing. I love it. I am fascinated by science. But the cool thing about weather is I can go outside right now and touch it, feel it, see it, and understand how it works. So it's something you can apply to everyday life. I got my start probably at 6 years old when we had a big snowstorm in Ohio. Fell in love with big snowstorms. We had a big blizzard when I was 6, and I remember going outside and snowdrifts being about 6 feet tall. I'm 6'3". So as a 6-year-old kid, I was just utterly fascinated by how the weather worked, and that's what I wanted to do. So one of the first things I always tell people to understand how the atmosphere works. You see a lot of it on TV. A lot of us look on our phones now, go online. But to really understand how the atmosphere works, there's really some simple principles that can help you figure out what's going on in the atmosphere. Understanding high and low pressure. High and low pressure are the key to everything. High pressure is the giant blue H that you see on TV or on a weather map. The big red L stands for low pressure. But they're really important to forecasting weather. In fact, before we had computers and Doppler radar and satellites, it really was understanding high and low pressure. So I always like to start off with talking to the kids out there about high pressure. Now, if you've ever dove to the deep end of the pool, I've got my daughter and my son over here. You guys ever dove to the deep end of the pool? Yeah. All right, Kinley, come over here. She's really shy, you can tell. So you've dove to the deep end of the pool before. What happens when you go down to the deep end and dive for a dive stick?
Your ears pop?
Yeah, you feel the pressure on your ears. Now, the reason your ears have that pressure is because there's a whole bunch of water above your head pushing down. High pressure in the atmosphere is just like that. There's a whole bunch of air above our heads. So when you think about high pressure, think about the atmosphere being thicker above our heads and pushing down. Now, low pressure is like going to the shallow end of the pool. You've got a little bit of water above your heads. And you probably have felt this as well. When we drove to the mountains, what happened to your ears?
My ears started popping.
They pop.
We were going up
the
mountain.
Or if you've been in an airplane or gone into a big building in a city and gone up in the elevator, your ears pop because there's less air above you pushing on you, so your ears want to expand. But there's also a really cool thing about high pressure, and I like to use my bike pump here. And my son's over there. He's just hanging out. He doesn't want to see. Let me pull up the comments here. So this is your basic bike pump or ball pump that you see. See if we can get that to pop up. So I want to make sure I see questions if you guys have them out there. So this basic pump is just what you use to pump up a soccer ball or basketball or football. And what I'm going to do is I'm going to push the air out. So you guys can hear that. I always talk about this is like my exercise for the morning as well. So I'm literally applying high pressure. I'm pushing air out of this bottom. So I'm pushing down on the air. And this is where I need Kinley. So at the end, there are two pieces of metal. There's one here and one here. So Kinley, I'm going to want you to touch this one in a minute after I pump it a couple more times. And I look really, really silly right now pumping this. This is a good workout, isn't it? Okay, touch that right there and tell everybody what you feel.
It's very hot.
It's very hot. Why do you think this is hot?
Because all the air is pushing out from that big tube all the way through the tiny one.
Yeah, so there's two things going on. This is two good lessons here. One, friction, because we're forcing air through that tiny hole, so we're squeezing it in there. But also, one of the impacts of high pressure, when you compress air, you create heat. And when you create heat, you dry things out. So when we have high pressure over us, it actually pushes down, it scours out the clouds, dries us out. Sometimes it heats us up. Some of our biggest heat waves in the summer are because of high pressure. But even in the winter, high pressure can be cool, but what it does is it clears the skies. Because just like a blow dryer for your hair, not that I need it, but you know when you do your blow dryer, it actually heats up the air and dries it out. So when you heat it up, you dry it out, that scours the clouds, and it typically creates nice weather. Now the opposite of high pressure is what?
Low pressure.
Low pressure. So the way we play with low pressure is we take a simple can of compressed air. Okay, in this can is compressed air. Currently it's under high pressure, but if I open the valve, I'm going to let air come out. Okay, so it's going to go from a state of high pressure to a state of low pressure. So let's do this. So it's just air, right? Just coming out. Now I would clean my computer off with this. Okay, feel the can and tell me what you feel. Mike's right here.
It is freezing.
It's freezing cold. So what happens in low pressure is when the air expands or is allowed to get into a state of lower pressure, it cools. Now when we cool things down, unlike the blow dryer which dries things out, when you cool things, if I press this long enough, there's a little bit of moisture on there, isn't there? I can actually get ice on here. So one of the impacts of low pressure, as the pressure goes down, the air expands, it cools, and because it cools, it condenses the water vapor into a cloud or moisture. Now, this is high pressure, this is low pressure. How do we measure this in the atmosphere? Do you know the instrument? You probably don't. Kyler, do you know the instrument? What's it called? It measures atmospheric pressure. And for everybody watching, it's called a barometer. Okay? A barometer. If you had to take away all my weather tools, I'm talking take away my computers, my Doppler radar, my smartphone, everything. If you gave me one instrument, I would want a barometer, because as the pressure goes up, guess what happens to the air? It gets warm and it dries out and we get sunny skies. As the pressure goes down, we see cool, wet conditions. The atmosphere would actually get cloudy and rainy. So pressure going up or down can really tell you a lot about how you see the atmosphere work. So my mic is a little muffled there, so we're going to put it right there. Is that better? Sound better? Okay. So we'll put it up there. So to continue this experiment for how the high and low pressure works, this is one of my favorite experiments, and I see you guys getting excited already. So what I have in this bottle, I have some liquid, which I'm shaking around. You guys can see it right now. So I'm shaking it around right now. I'm creating vapor in here. This is actually pure rubbing alcohol, about 96% alcohol. Got to save that too, because you might want to make hand sanitizer with it. But we're doing this for an experiment to create a vapor in there. So just like in this room right now, you guys can't see it. You can't see it at home. There's little tiny droplets of water in the air. That's called water vapor. They're so spread out, you were looking, they were so spread out that you can't really see them until we smush them all together, and then that would condense into a cloud. So what I'm doing here is I'm creating it there. So I'll show this really close to the camera. You guys can see it's completely clear in there. So what I'm going to do, we're going to take our pump and we're going to do high pressure. So we're going to pump this up. We're going to attach it to the top. And I hope this works, because this has to be an airtight seal. So what I'm going to do is I'm going to take the pump and I'm starting to pump up my bottle. So this is my second whole workout of the day, right? Oh, thanks, Kinley. Okay, Kinley, you're going to tell me, is it starting to get really hard?
Yeah.
So when I do this at school, it's really funny because all the kids want to sit in front of me, and I'll pump this up, and all of a sudden the kids in the front start doing this, because they realize if I keep pumping, that this is probably going to explode, isn't it? I hear a little leak, so here, let it sit for a second. Let me see. Okay. I hear a tiny little leak. Where's it leaking?
From right there.
Okay, let me see if I can see it. There we go. Oh, yeah. All right, there we go. So I'm going to pump it up real hard. So what I'm doing is I'm creating high pressure. I'm pumping a lot of air in here. Tell me when it gets really hard. Can you feel it? So I can counteract a leak by over pumping it. Oh yeah, that's getting really hard. So maybe do it a couple more times. Okay, now watch this. This is the best part of this experiment. Okay, let go. Ooh. So we took the top off real quickly. That scared you? We took the top off real quickly, and what happened was the air in here was under high pressure. Remember, I was pumping it up big time, creating big high pressure. The dog's freaking out right now because he heard that. We created a big area of high pressure. When the air expanded, what happened? It cooled down really, really quickly, and that caused it to condense into a cloud. So we created a cloud. Hey, Kyle, will you touch my touchpad so the computer doesn't go to sleep? There you go. That's only bad though doing a computer. So we created a cloud. So low pressure, when the air expands, it cools, it creates a cloud. Now I want you to watch. I don't know if you guys can see it in there. Watch what happens when I pump it back up. You hold it for me, Kimmy, on the side so they can see it? I'm going to pump it back up. Watch what happens to the cloud. What happened to it, guys? It disappeared. So a simple principle of high and low pressure, when there is low pressure, you can actually get a cloud to form. This happens in the atmosphere by either a cold front, a warm front. Anything that forces the air up into the sky will cause low pressure. We call that uplift or updrafts. Now, why this is so important in the atmosphere is if you have a barometer, a simple barometer, most of the first settlers that came to the United States overseas, the ships, they had a barometer on it. You don't even need to know the measurements or units of measurement, though it's great. Sometimes it's measured in inches of mercury, in millimeters of mercury, or we'll use millibars. All you got to do is watch the trend. Is the pressure going up or down? Oh, the dog's barking because the mailman's here. The pressure going up or down will tell you a lot about whether it's going to get cloudy and maybe even rainy or cool, or sunny and dry. So what they would do is they would see the pressure's going up. That means the weather in the next 24 hours is actually going to get better. When the pressure falls, they know it's going to get rainy and cloudy. And here's a really cool tip. Everybody's smartphone actually has a barometer in it. Do you know why there's a barometer in your smartphone, Kinley? She's only 8, so she won't know. Kyler, why is there a barometer in here?
I don't know.
So think about what a barometer can tell you. Since it tells you the atmospheric pressure, and we know as we drive into the mountains what happens to our ears. Pops. So guess what the barometer in the smartphone tells you? Yes, how high you are. So for GPS functionality, and also for your location, it tells you your altitude, basically. An altimeter is another form of barometer. So every smartphone has a barometer in it. Now, it's used for GPS and for location to tell you your elevation above sea level, but you can actually access it with a lot of apps. So one of the things I do is I always pull up, at least in iOS, there's a smartphone app that will let you access. Hawk loves the barometer. It's okay, buddy. He's okay. That's when somebody comes to my house. Thank you. We're practicing social distancing, but the dog is not into it. So the barometer right now on my smartphone, I don't know if you guys can see it, it'll tell me it's 1,006 millibars, and it tells me I'm 603 feet above sea level. So if you're at home and you have an Android device or an iPhone, look for a barometer app. And one of the cool things you can do with your kids is track the barometer. You can actually put the needle on here and watch the trends, and then look at the weather, observe what's going on outside. So today, the pressure is pretty high. In fact, the trend is pretty high right now. But it'll tell you also at the bottom, if the pressure begins to fall, it'll tell you there could be bad weather coming. So a really cool tool to help you understand how the atmosphere works is understanding the barometer. But what if you don't have a barometer? How could you figure out what is going on with the weather? So we're reading all the comments here. You guys, any good questions, you let me know if you guys have questions as a kid. So one of the ways you can figure out if higher pressure is moving in is also by using another instrument. One of the cool things about high and low pressure, Kyler, is that they spin a certain way in the atmosphere. So guess what happens at high pressure? It spins clockwise. I got to turn my back to you guys. Clockwise. You guys know what a clock looks like, right? Most people don't even know analog clocks. It spins this way, okay? Low pressure spins counterclockwise. So if I didn't have a barometer and I wanted to figure out what the weather was going to be, what instrument could I use to figure out if high or low pressure was moving? If I didn't have a barometer, knowing that they rotate a certain way. What is it called? I got that. We have a weather station here. We need a weather vane or a wind vane. Have you ever heard of a weather vane or wind vane? So this is a wind vane. That's its accurate term. So a wind vane tells us the direction of the wind, but sometimes you may have referred to it as a weather vane. Okay? Why is it sometimes called a weather vane? Well, because it can tell us the direction of the wind, and if it's coming from the south, we know low pressure is moving in. If it's coming from the north, we know high pressure is moving in because the way those pressure systems rotate in the northern hemisphere. This is only for the northern hemisphere. You got to flip everything for the southern hemisphere. So you probably growing up, a lot of the parents watching out there right now, you probably growing up or even read in books as kids, you've ever seen the rooster? Hey guys, you ever seen the rooster on the barn?
Yeah.
With the wind vane on it? Mm-hmm. Why does a farmer put that on their barn?
So they know which way the wind
is going. But what does that tell them? It actually helps them forecast the weather. So within about a 24-hour period, if you know if the wind's coming from the north, you know high pressure is moving in and that the weather's probably going to get nice. If the wind's from the south, you usually know low pressure or a front is heading your way. And so today, we're going to notice over the next 24 hours, notice something you can do with your kids, what direction is the wind starting to come. It's going to warm up dramatically. We're going to see south winds, which means that low pressure is on the way. Now, the only caveat with this, and this is how modern technology has helped us out, these parameters are only good within a time frame of 1 to 2 days. So they're not really specific, but before we had instruments and satellites and radar and all the cool tools we have now for meteorology, barometers and wind vanes and weather vanes were the way that we helped forecast the weather, just by observing what was going on and understanding how the atmosphere moves. Now, up here is the instrument that Kyler was all excited about. What's this called? This has got a funny name. It's got a lot of consonants. It's an anemometer, okay? An anemometer is basically a speedometer for the wind. So the way I think about, hey guys, let's not worry about that right now. You guys are so into the comments, you're not paying attention over here. This is the dilemma at home right here, right guys? We're always distracted. So the anemometer is the speedometer for the wind, okay? It tells us how fast the wind is going. So blowing on it shows us that it spins in the wind. This is a certain type of anemometer called a cup anemometer. So the cup anemometer has little ice cream scoops that catch the wind as it blows around. Now there's other types of anemometers. A windsock is a form of an anemometer. It's basically an anemometer and a wind vane in one. It points the direction that the wind is blowing, and it also shows us how strong the wind is blowing by how far out the windsock is. Now within our basic weather station, there's also two other instruments down here. You know what those other two instruments are? One is the simple one that everybody knows, a thermometer. There's also something in here called a hygrometer. Does anyone know what a hygrometer is? Guess. What are you guys wondering? What's a hygrometer? Don't cheat. You can't look. A hygrometer measures the amount of moisture in the air. So basically it measures humidity. So think of hygrometer. Hygrometer is like hydro, anything with moisture. So a hygrometer measures the amount of moisture in here. Now you guys might know this because you live with me, but at home and everybody watching online, there's two plates right here. They're upside down looking plate things. These are radiation shields. Okay? When I say radiation shield, most people are like, oh my gosh, what are you guys tracking? This is, you know, is this a nuclear power plant? What are we worried about? What type of radiation are we shielding this from, Kyler?
The sun.
The sun, ultraviolet radiation. It's the biggest form of radiation on our planet, and people forget about it all the time. It's what causes a sunburn. It's what heats us up when we go outside. It heats the ground up, which then heats the air up. And the reason we have these upside down plates, these radiation shields, is this is a good thing to have if you're at home and you have an at-home weather station. You ever wonder why your weather station reads crazy compared to what I'm showing on TV? Now, it could be warmer or cooler at your house, but usually it's because you don't have a radiation shield. Remember, we don't want the temperature of the sun. We don't want the temperature of the sun hitting the ground. We want the air temperature. Just like now, when you go to the doctor and they're going to take your temperature to see if you've got a fever, they put it under your tongue or they take a temperature to get your internal body temperature. They want an accurate measurement. For the air temperature, we want to take the temperature, not in the shade, in complete darkness. Because complete darkness means there's no light and there's no ultraviolet radiation. So most weather stations have this completely sealed up where there's no sunlight or indirect sunlight, which then basically gives you the temperature of the air. So some of the thermometers at the airports and some of the other big weather sensors actually take air into a tube, blows it across the thermometer, and it exits its pipe, and that thermometer never sees the light of day. So a lot of folks, will say, hey, that's a temperature in the shade. It's actually not. It's a temperature in complete darkness because it's the air temperature, not the temperature of the ground. So in your car, go ahead and touch that one time, God. So in your car, if you see the thermometer on your dashboard and it reads really crazy high, Those can be accurate if you're driving for a while and you get air over them. The problem is oftentimes it's the temperature of the bumper, the engine, the ground below it. It's not really the air temperature. That's why during the summer heat wave, I'll get a million tweets at me and Facebook posts showing it's 110 in their car, and that's the sun hitting something. It's not the actual air temperature. So this is one part of a weather station, okay? There are probably, I'm guessing in the United States, close to 500,000 of these now. We have 2 on our roof. The airport has one. A lot of people have them at their house. A lot of schools have them. They're collecting data all the time. But there's one part of the weather station we haven't mentioned yet. You know what that is?
The thing that shows how much rain.
Yes. So do you know what this is online and at home? This is actually a rain gauge, but this is a specific type of rain gauge. This is what it looks like when it's broken. Okay, and this has been outside for a long time. So I'll show you the difference. What ultraviolet radiation does, that's one that's been outside for a long time. Here's what it looks like brand new. So you can see when the sunlight will have a big impact on plastic. So there's a look at it full. This is just a funnel. You guys see that hole right there? That hole right there sits on top, and this is called a tipping bucket rain gauge. So I don't know if you guys can see that. There's a little teeter-totter or seesaw. So this bucket sits below the funnel. The funnel will catch rain. It will go into that bucket. That bucket holds exactly 0.04. So when it gets full, guess what happens?
It tips over.
It tips over and it dumps it out the bottom. And now the other side starts filling up. This side holds exactly 0.04. When it fills up, guess what happens? It tips.
And then
it tips twice. How much rain did we just have? The easiest math I do all day, 0.04 plus 0.04 is what? 0.08. Yes. So a simple adding of the tips, if you will. So when we have a big rainstorm, like if it's raining real heavy, like it seemed like it's been doing all winter, this thing can be going like this because it's raining so hard. But if it's barely raining, guess what happens? It just does this once an hour. Because I don't just want to know how much rain is falling, I want to know how fast. And how fast is important because if it rains an inch in a day, that's actually not that big a deal. But if it rains an inch in 15 minutes, guess what happens? Floods. Yes, we get a flash flood. So the rainfall rate is really important. But this is just one type of rain gauge. We've got other type of rain gauges. This one's kind of silly. It's a giant one, and you can actually fill water up in it, and as it fills up, this little float goes up. But notice that it reads to the nearest quarter of an inch. Okay, I told you this one read to the nearest 0.04. This one reads to the nearest quarter of an inch. This is not very accurate, though you can stick it out in the yard and see it from a mile away. The most accurate way that we measure rainfall is with a manual rain gauge that looks like this. It has a tube in it, and I don't know if you guys can see that tube, but it's got little tick marks on it that look like a ruler. And guys, you see those little tick marks? Each one of those is the lowest measurement of rainfall that we make, which is 0.01. 1/100th of an inch. And this rain gauge is really cool. So it sits on top like this. There's a funnel, and as it rains, it fills up. So this holds 1 inch of water. You can actually see the 1 inch at the top there. I don't know if you guys can see it. We'll put it right there. But this holds an additional 5 inches. So what happens is this is an overflow. Once the rain goes in there and overflows, I have to go out and check this. This is the only bad thing about this gauge. These gauges are automated. They'll send me data remotely. I don't have to go outside and get wet, but it only measures the nearest 4/100ths. I want to measure the most accurate way possible. I have to go outside and check this every morning. Kyler, we have one back, right?
Yeah.
We check it every morning. We see how much rain. What happens when it's really full? We take it out and we say, uh-oh, there's an inch. And what do? I dump it out. And I take whatever water's left in here from the overflow and we fill this up. And if it fills up again, I'll dump it out and go 2 inches. And if there's any water left, I'll dump it in here and it'll go to 1/2 inch, and that would be 2.5 inches of rain. Now the cool thing is this holds 5 inches, this holds 6. So total, you've got 1 inch and 5, total 6 is what I meant. So 1 inch and 5 inches of overflow, so 6 inches of rain can be in here. So that's a lot of rain, but you got to check this every hour, 2 hours, 3 hours, 12 hours, or 24 hours. so that you know how much rain fell in that time period. So really, if you want to become a spotter for us, like weather-wise, this is called a CocoRuz rain gauge. They're about $30. This is what the Weather Service does, because temperature does vary quite a bit across the area, but rainfall varies much more dramatically. The rainfall at the airport in your house is always going to be different. So these backyard gauges are really important. And there's actually a third type of rain gauge we have in our house, and it's a really cool one. It's called a haptic rain gauge. The weather station on our roof, Kyler loves it because it's very futuristic. It's a haptic rain gauge. It's got a plate on the top, and it actually measures the individual raindrops that hit it, and it calculates how much rain is falling and how hard based on the number of impacts of raindrops. So the only bad thing about that, what happens sometimes when the bird lands on it?
It counts as a raindrop.
Well, it thinks it's raining. It gives us a notification on my watch and phone that it's raining. But the good news is the software is so good, if it doesn't get another impact within a certain amount of time, it knows it was a bird, and it cancels the data out. So it's really cool. Now, it's not as accurate as this, but the nice thing is there's no cleaning it out. There's no emptying. It's just going to give us rainfall data. The other cool thing about our weather station is it has an anemometer and a wind vane that doesn't move. It's ultrasonic. It's two plates that have sound waves that go between it, and when the wind blows through it, it measures how fast the wind is going. So weather stations are a great way to teach science at home or school, because one of the things about weather is that you can observe it, and that's a great thing that I would say during this social distancing and isolationism that we're in right now because of the coronavirus, is if you want a project to do at home, it's a simple thing to just keep track of the weather for the whole week. Watch us on TV, see what the high and low was. We'll sometimes say, we don't always say it on TV, but you can always check on our website or go online and check it. Or if you have a weather station or a thermometer at home, measure the temperature every day and then average it out for the week, and it's a simple math trick. You can basically just, hey, this is how warm it was this week. We can average it out. This was our average high and low. So it's really a cool way you can observe what happens every day. And also with the barometer app, I think it's really cool, is keep track of the sky condition. Was it sunny and warm, and what was the barometer? And then you can start doing the correlation of how you could forecast the weather by studying the barometer. So why do we do all this? I mean, why do we collect all this information?
To protect people if it's like a hurricane.
Yeah, the main reason we do this is to forecast the weather. We're trying to figure out what the atmosphere is going to do, because these weather stations, not only in the United States do we have about 500,000, there's millions of these all over the world collecting data every minute, every hour, every day, 24 hours a day. This year, 366 days a year, but normally 365 days a year. It is leap year, so we have an extra day. And all that data is fed into a giant video game. My son's going to smile because he loves video games. Now, my video game isn't quite as cool as Kyler's video game, which is Minecraft. He loves Minecraft. But my video game is a simulation of the atmosphere into the future. And just like the video games you guys play at home, when you interact with it with the controller, what happens? You change the outcome of the game. Okay? My job as a meteorologist is to look at all these simulations. And by the way, most of us know that there's weather models out there, but you probably don't know there's 30, 40, 50 different ones, and there's variations. In fact, the ensembles of the GFS model, which is the American model, and the European model, between the two of those, you've got close to 93 different runs every 6 to 12 hours. So my job as a meteorologist is to figure out how things interact with that future world or that simulation, and how it's going to change the outcome. So we still have a really important job as meteorologists, because we have to basically figure out how the model is telling us things are going to happen, but also if we see influence from somebody with a controller, in this case it's not a person, in many cases it's a cold front or a warm front or high pressure, low pressure, that's going to change the outcome of the model. But as Kyler was mentioning, one of the most important things that we have to forecast is severe weather. Forecasting sunny and 80 is awesome, which I will forecast tomorrow and again on Friday, but the problem on Friday, we're going to see low 80s, but we're probably going to see a chance of thunderstorms. And my job as a meteorologist, probably the most important job I have, is to keep people safe and to forecast severe weather, because that is really the most vital thing that we do as meteorologists. Now, weather forecasts in general are very important. A lot of people take them for granted because they don't really see what goes on behind the scenes, but a lot of us will be ordering Amazon Prime here in the next couple weeks. It's going to be backlogged, but typically Amazon Prime, when there isn't a crisis going on, will get to your house in 2 days, right? Unless there's a delay. Well, guess what? Amazon has to not ship that stuff through thunderstorms blizzards, floods, hurricanes, so it gets to your house. So logistics are really important. Weather is really important to the shipping industry, commerce. That's why the National Weather Service and NOAA is actually in the Department of Commerce, because it's so vital. Farmers, every farmer's got to know what's going on with the weather. Every airline needs to know what's going on with the weather. And every insurance company. In fact, I just had my roof replaced, and one of the ways they figure out whether your roof gets replaced is by checking out whether it gets hail or wind damage. And also, the premium you pay on your house is going to be based on whether the threat of your home being hit by certain weather events. So meteorologists, we see a lot of us on TV, a lot of you watch me on TV, we make up a very tiny part of the meteorology community. There's probably only about 5% of us in the meteorology community that work on TV. 95% of us work in other businesses: energy, transportation, insurance, emergency management. Meteorologists are all over the place. In fact, Carowinds, they hire meteorologists remotely to help forecast the weather for their park. Charlotte Motor Speedway, the City of Charlotte, DOT. So the really important job, but the most important thing that we forecast, as Kyler said, is severe weather. So I'm going to have you guys, can you take care of those, Kyler? Thank you, my assistants. We'll move these out of the way. So one of the things that's really important to forecasting severe weather is understanding. I'm going to see if we have any comments here, guys, that we can answer while we're sitting here. Severe weather is really important, and the type of severe weather, thank you, honey, the type of severe weather we get around here are severe thunderstorms. Now, one of the things that we get from severe thunderstorms that I'm always very wary of is hail. I chased tornadoes for 2 years in college, and I hate hail. People always ask me, are the tornadoes scary? Really not. It's really more so, she's a great assistant. It's really the hail that I worry about, and I have a couple examples here. I stole your balls, Kyler, sorry. I stole a couple of your play balls here. So I bought one of your golf balls. So this is a golf ball. Golf ball is about 1.5 inch in diameter. Put that there. Baseball is about 2.5 inches to 2 3/4 diameter. This one looks a little bit smaller. And then we've got a softball size or grapefruit size, which is about the 4.5 inches in diameter. So the way hail forms is, just like most severe weather, you need two pretty vital ingredients. One is wind shear, which is the wind changing direction with height. So if we're down here at the ground and the wind's coming this direction, as we go up in the atmosphere, the wind changes direction. We call that wind shear. And wind shear happens quite a bit. We'll probably see some wind shear today outside, because you'll see leaves or trash swirling around in your yard, your playground, the parking lot, out in the street. That's a sign of wind shear. But we need something else to create severe weather. We need strong wind shear, and we need an updraft. You guys know what an updraft is? Kinda. Well, the way I describe an updraft is wind going from the ground up into the sky. Okay, most people think wind goes horizontal, and it does, but there's another component of the wind. It's the vertical component, which we call an updraft. So updrafts are really, really important to getting severe weather, because they take warm, humid air near the ground, and it takes it high up in the sky where it's colder and drier. We call that instability, when it's really warm down low and super cold up high. Now, it's always warm down low and cold, but when that temperature difference gets exaggerated, the atmosphere becomes unstable. And instability combined with wind shear is a bad combination. So the way hail works is an updraft will take a piece of water, a droplet of water in this case, from the bottom of a cloud or a thunderstorm, and it'll blow it to the top of the thunderstorm, where it could be 20 or 30 below zero. It'll freeze. The water droplet will be frozen. It'll fall as a piece of ice, but guess what? As it falls, it gets trapped in that updraft again. It gets taken back to the top, and it refreezes again. And then it falls back down. It gets wet again, and it gets blown back up. So it'll go through this cycle until this gets so big or heavy, or it moves where the updraft can't keep it up, and it'll fall out of the cloud. Now, the cool thing about hail, that you don't want it to hit your car, because golf ball size hail is about the size that causes damage to your roof and your car. But if you see pea-size hail, which is typically the size we get, marble size, go outside after the storm is over. Do not go out there in the middle of the storm, and break that piece of hail open. Inside, you'll see rings. Each ring will represent the number of times that piece of hail went through that cycle. So big hail will have a whole bunch of rings, maybe 3 or 4 or 5 in there. And also the size of the hail can be directly correlated to how strong the updraft is. But here's the thing about updrafts. What goes up must come down. So if something goes straight up, it's going to fall back down. And it's actually going to cancel itself out. So pop-up storms in the summer are actually the ones that build up because the updraft goes up and they actually collapse on themselves and they cancel each other out. Because think about it, if you have an updraft coming up and a downdraft coming out, they just hit each other and they cancel each other out. So in that case, an updraft and downdraft actually causes the storm to fall apart. So that's your typical pop-up popcorn kind of afternoon storm that bubbles up, and this is the one where everybody tells me, hey, it rained over here, but it always misses my house. That's because that's a type of thunderstorm that doesn't last very long. But there's an updraft that can last a long time and also cause severe weather. It's when the updraft is tilted slightly from the downdraft. And what happens is the updraft goes up, the downdraft is off to the side, and it creates a convection current. You probably have a convection oven at home that is the same principle. It continues to go up and down. It circulates the air. Convection currents is actually the reason we call thunderstorms in general convection meteorologically. That actually causes the storm to maintain itself and actually can produce giant hail. So this is where I bring my leaf blower in. So this is probably going to be pretty loud. So here's my leaf blower, and I'm going to stand back here a little bit so you guys can see it. So what I'm going to do is I'm going to put the ball in here, and I'm going to show you if I have a vertical updraft, this hail is going to go up and come straight back down. It's going to want to do that. That's what I need my assistance for. Oops, sorry guys. Thank you. But I'm going to show you how the updraft can maintain it and be tilted at the same time. So here's the vertical updraft. So I'm going to stand back so I got room for it. So let's do the vertical updraft. Here we go. But watch as I tilt it. Even though it's tilted, it's still holding it up there until it gets far enough away that it falls out. And the reason that hail gets gigantic like this, like softball size, is because it can stay up there for a long period of time and get refrozen again. So a softball sized piece of hail like this actually probably has an updraft that's sustaining it that's 100 miles per hour, 100 mile per hour wind going up into the sky. This is why airplanes stay far away from thunderstorms, because not only are there strong updrafts, there's also strong downdrafts. And if you're flying straight through that, the plane will go like this. And sometimes it gets pushed all the way to the ground, sometimes it gets bumped up. So updrafts are around quite a bit. There'll be a couple today in the form of cumulus clouds. This is also why you get bumpy flights when you fly through every cloud, because every cloud is typically a little updraft. Now, if you ever want to figure out where an updraft is without actually seeing it, birds help us out. Okay, Kyler, you know this. All right, you ever seen those big black turkey vultures circling in the sky? Right?
Yes.
Everybody in every movie I watched since I was a kid would say, oh, something's dead. There's turkey vultures circling. But here's the thing. Turkey vultures are looking for food, and they do eat dead animals. Doesn't mean something's dead there. Turkey vultures are incredibly lazy birds. They don't like to expend any energy. They want to use all their energy to actually eat food. So what they do is, if you watch them next time, and we'll see today, I bet we'll see some today. If you see some circling, this is a great thing to do with the kids as well. Go outside. If you see those turkey vultures circling, just take a second and watch them. Observe them. They will have their wings wide out. They'll be circling. And guess what happens? Without flapping their wings,
They'll go up.
They're getting higher in the sky. They're not, watch, they won't flap their wings and they'll get higher and higher. You know what they're doing? They have found an updraft or a thermal. And they've used that to get higher in the sky to look for food without having to expend any energy. And when that updraft collapses, what do? They circle over and they find another one. So when you see birds circling like that, it's not that something's dead, it's that they have found an updraft. So as a meteorologist, when I see that, I immediately go, ooh, we've got some pretty good updrafts. And in my old chasing days, when we used to chase tornadoes, before we had radar on our phone, I feel like I'm from Twister, we used to roll the maps, not fold them. We used to look for those birds circling to see where the updrafts were starting to go. And then you'll see a cumulus cloud, a towering cumulus cloud. You know the updrafts have started, and the cap is broken, and we're going to get some severe weather. So hail is one part of severe thunderstorms. Severe thunderstorms that produce hail are what we sometimes refer to as supercells. That means they have a rotating updraft. And rotating updrafts are a clear sign of a mesocyclone, which means bad news. We could have what? A tornado. Okay? So today I want to talk about tornadoes because, as you guys know, can we go touch the screen again? We had a tornado come through my backyard. So what I'm going to do here is I brought my tornado simulator. I didn't bring it anywhere, it's always at my house. I'm going to show you how a tornado forms. So, excuse me, Hawk.
Yes.
I don't need that yet. So what I have in here, just so you guys know at home, this is just a water in here. What I've done is I put what amounts to an ultrasonic anemometer. It's taking electricity and it's going to convert liquid water to a gas, water vapor. So here we go. So I'm making an artificial cloud so you guys can see it there. We'll let this build up for a second. Okay. Remember the two ingredients we need for severe storms, in particular tornadoes, are what? Wind shear and an updraft. So we need wind changing direction with height, and we also need an updraft. So to put on top of this, I'm going to put the top of our tornado maker. It has little pipes here that have holes in each one. Each pipe has a hole in it that's going to simulate wind shear. Then on top, we have a fan that's going to create the updraft. So I'm going to put this on top. It's got a hole right there. We'll stick it right here. Hopefully this works. You guys can see it at home. Okay, we're going to put this on. This will help you give you better visibility at home. And if we have to, we'll use a light so you guys can see it. So I'm going to put it right here. Let me pull it right there so you guys can see it. I got a light in case we need it. So the first thing I'm going to do is I'm going to turn the wind shear on. So the wind shear, I want you to observe what happens at the bottom. So guys, let this build up and don't get too close to it because this is important. You have to have good wind flow. So we'll turn the wind shear on. Whoops, I got to plug it in. That would help.
Yeah.
Turn that off. This is why anytime I do a school talk, I'm always like, I need to have a plug and a table nearby. Okay. So we're turning the wind shear on first. And let's see what happens down here at the bottom. I'm going to use my light. Whoops. So down here at the bottom, I don't know if you guys can see it. I'm going to turn this towards the camera just there. There we go. So we got that right there. Look at what's going on at the bottom. You see that? How it's just kind of swirling around? So guys, this is like the trash or the leaves in the yard or outside that swirls around on a breezy day. And we see this all the time. It's not a big deal. But watch what happens when we introduce an updraft. Ready? So you guys can see we have a pretty good tornado right there. Okay? Now the cool thing about this, and this is the reason I love this teaching tornado, is having seen about 60 tornadoes close up in my life with chasing and stuff, they behave a lot like this. And everyone, all the kids watching online, I know it might be a little hard to see, but I want you to watch the behavior of this tornado. Notice how at times, let me see if that light works better this way. We'll shine it this way. There we go.
I think we need that big one over there now.
Yeah. Oh, you're blocking. Here, you don't have to hold this on. Yeah, there we go.
Do we even need it?
Here, turn the overhead light off. We'll see if it helps show it up. No, that light on the wall, the switch. All right, that helps a little bit. There we go. That's a little bit better. So you guys can see the tornado swirling around in there. And notice how it collapses. At times it gets skinny, it gets wide. It also is hollow. There is an eye of a tornado, believe it or not. No, leave those open, hon. The eye of the tornado is actually a part of sinking air, but you never want to get in there. And the thing about tornadoes that we get about 1,300 on average over the last couple of years in the United States. We are the tornado capital of the world, and people don't realize that. We get more tornadoes in the United States than most of the world combined. I mean, especially between the United States and Canada, North America, we have kind of the perfect geography. If you think about the map of the United States and North America, we have continuous land from the middle of the U.S. all the way to the Arctic Circle, and we have continuous land all the way down to the Gulf of Mexico, which is a warm body of water. Then on the east and west coast, what do we have? We have mountain chains, which funnel the warm, humid air up to the north and brings in strong jet stream winds that come out of the Rockies and brings us cold fronts and low pressure systems that all combine. Now, it's not a simple thing of cold and hot. People think that. That doesn't make tornadoes. You need to have strong wind shear, and the jet stream is really important. That's why we get most of our tornadoes in the spring and in the fall, that's the time of year that we have the strong jet stream associated with the winter time, but we also have some warm, humid air. In the middle of the summer, we do get tornadoes, but they happen more up in Canada than they do down here. So Kyler, turn that light back on, and I'm going to let this continue to run. I'll leave my light here. Maybe this will help kind of show you. But one of the things that I tell people about tornadoes is inside there, the average tornado is only about maybe half a football field wide. And in many cases, tornadoes are very tiny. They only last a matter of minutes. The average, tornado might be an EF0, EF1. Occasionally we get big tornadoes, but they're pretty rare. Now, what makes tornadoes dangerous, and this is what really blows people's minds, and I'll tell you this, it's not always the wind, okay? And people are like, what do you mean it's not the wind, Brad? We're worried about tornadoes because of what they pick up. The wind picks up and throws at you. Most people have seen The Wizard of Oz or they've seen Twister, and they all think they're going to get sucked up, okay? That's actually not very likely. Most people, 80% of the people that get hurt in tornadoes have head trauma. So Kyler, go grab your bike helmet for me out of the garage. Because one of the things I want to tell you about is tornado safety. Because tornadoes are going to happen. We get in the United States a ton, but in North Carolina we get about 32 a year, and in South Carolina it's about 26. Every year it's a little different. We're off to a record start this year. So we're probably going to surpass that. And we're just heading into the tornado season. One of the things that I talk about with wind being not the dangerous part is I bring my leaf blower out. So, Kinley, so if I have my leaf blower, and I do this to the kids in school, if I use a leaf blower and do that, it blows you around. It's not a big deal, right?
Yeah.
But what if I stuck rocks in here, nails, glass, stuff, and then I did that? You probably wouldn't want to be there, right? So the most dangerous thing in a tornado is what the tornado picks up and throws at you. So Kyler did a great thing. He went and got his helmet. When we do tornado warnings and tornado drills, one of the things I want you to do is look in your house. Where is the middle of the house, in the interior room, away from the outside walls and windows? The reason we tell you that is to block that debris. Every wall is like a force field that will protect your house, and really not protect your house, but protect you in your house from flying debris. So if the first wall doesn't block it, the next one will. If the next one doesn't, the third one. And then if it gets to the room you're at, hopefully it doesn't make it through the wall. And this is your last line of defense, right? Come here, I want you to put this on. If there's a tornado warning, I want you to have a helmet. And I want you to put it on. I don't care if it's a skateboard helmet, bike helmet, football, hard hat, anything. Put a helmet on your head, because I want the debris to protect you. So in school, when you guys did your tornado drills, what did you do, guys? You got down and covered your heads up, right?
Basically, sometimes we get under a table and we do this.
Yes. Protecting your head is important. So in a tornado, and I want you to do this today while you guys are home for the next couple of weeks, go in your house right now. What's the room you go into? I'm going to show you a quiz. Guys, where would we go in a tornado? See, they know exactly where to go. And that's the thing. The average tornado warning is about 9 minutes. Okay? 9 minutes. That's if you're watching me or watching anybody or getting your phone and you see at the beginning. On average, people get it about halfway or 3/4 full. So you're talking a couple minutes. If everyone's looking at each other going, where do we go? That's a problem. So have a plan ahead of time. So I tell these guys, and I did with the tornado went back on February 6th when it hit our backyard, was I told them a couple days ahead of time, go get your helmets, go put them in there, clean out a spot in the closet and get ready. Luckily they were at school away from here, but my wife was home, grabbed the helmet, put it on, got the dog, and got in the closet. So that's what you guys need to do, is think about where you're going to go in your house. Now, the other interesting thing about tornadoes is even though we get so many of them, they're incredibly fragile. And that's the thing that fascinates me about them, is that as dangerous as they are and as many as we get, you can easily destroy them. You have to have the perfect ingredients together to get a tornado. So tornadoes, while they're very scary, are often very fragile, and it takes a lot to get them to form. Now the thing to remember, here back up for a second. So the thing to remember about this tornado is there's a thunderstorm above it that's about the size of the county. So the tornado gets all the press, right? It's the media, everybody's obsessed with where the tornado is. Here's the thing, 90% of wind damage in North Carolina comes from straight line winds, not tornadoes, okay? That tornado's rotating at maybe 170 miles per hour. The strongest tornado on record, there's a debate whether it's the El Reno tornado back in 2013. It might have had winds close to, it might have had winds close to 330 miles per hour. but it most likely is the Oklahoma City tornado in May of 1999 that had winds of around 318 miles per hour. So what I was saying about tornadoes is that, you know, they can be up to 300 miles per hour, but most are in that 70 to 80, 90 mile per hour range. And the thing is, everyone thinks I have damage to my house. It had to be a tornado. Here's the thing. If a 70 mile per hour wind is going to break your roof or break a branch or take a tree down, it doesn't matter what causes the 70 mile an hour wind. We have a saying, wind is wind. So when you get wind, if something breaks at this threshold, it doesn't matter what causes that threshold, it's going to break. So in general, the straight line winds associated with this tornado are going to be much, much stronger. In fact, what happens is this big storm, all this air is being sucked up. It's going to the top, it's cooling, it's getting super, super dense and heavy. It comes crashing back to the ground as a straight line wind. We call it a rear flank downdraft. And sometimes that's as wide as a thunderstorm. That tornado is only 50 yards wide. The thunderstorm is like 50 yards or 50 miles wide. Okay? So when I see widespread damage, people say it looks like a tornado came through. I normally will tell them the more widespread the damage, the more likely it was straight line winds. Tornadoes cause isolated damage in very tiny spots across the area. So something to keep in mind that you're going to see is potentially some strong straight line winds. You're also going to see really large hail. You're also going to see a lot of lightning. So lightning safety tips. What do we say about lightning, guys, when there's lightning going on? Stay out of the bathtub and the shower. That is not an old wives' tale, because if lightning hits the ground outside your house or the plumbing system, the electricity will travel through the pipes into where you are. It doesn't matter if you have copper pipes, and people always tell me I have PVC pipes. It doesn't matter. If there's water, conducts electricity. If there's water in the pipe, it will take electricity in. So also gamers like Kyler, he has cordless Xbox controllers. If you have corded ones, don't use them during a thunderstorm. Back when people actually had landlines, we told you not to get on the phone that was connected to the wall. Anything connected to the outside is going to get hit by lightning. It can bring it in. The same way electricity gets in your house, or power, or water, or cable, is the way electricity gets in. So just remember that the next time there's a big lightning storm. The threshold for severe thunderstorms are 58 mile an hour winds and 1-inch diameter hail. So just remember that you're going to see that potential, that you're going to see some big time lightning. So I'm going to go through some of the comments here. I got to catch up. Kinley was kind of going through here.
I was trying to tell you some of the questions.
I know, I'm going to read some of them. So,
asking, and they're quickly disappearing.
We still have a landline. I love it. So there's some pretty good questions on there. The one thing I'll tell you guys, we're going to wrap it up. We're coming up at 1 hour here with the stream, is that if you have further questions about weather or climate or science, we're going to be doing a series of 5-minute videos starting next week at WCNC. So every day around 11 a.m., Monday through Friday next week, and the following week, the First Warn Weather Team, we're going to put together one thing a day, 5 minutes talking about, let's say, tornadoes or lightning or something specific, and we'll do those. And we want to take questions. So after the first week, if there's a topic or something you want us to cover, let us know. These will be live at 11 a.m., but they'll also be recorded, just like this video will. We will post this directly to Facebook, YouTube. It'll be on our website as well. I think we're recording back at the station. And we'll post this online so you can go back and use it again. And again, hopefully we'll get over this thing, and at some point we'll be back in school. And if you want me to come out to your school in the fall, we can do a similar presentation and talk about it. Yes, honey?
Some people are asking you to turn off your mic.
No, it's on. It's working. I'm just scrolling through here. So if you guys missed anything, go back. Kyler's checking it out from above. Thank you to Kyler and Kinley and Hawk, who you saw in the background wandering around. I'll probably do more Facebook Live type videos over the next couple of weeks to help you guys out, talking about the upcoming weather. Because remember, even though we're stuck at home, there's going to be a lot of weather stuff going on, and we'll keep you informed as we go through this over the next couple of weeks. Thanks again, everybody. The timing, it worked out pretty perfectly. Right around 11:55. Typically, if I was in school, I would take questions, but I don't see a whole lot in here. Any questions, bud? Here, let me get up. You're blocking my way to the computer. All right, everybody. See you later.